Hey everybody, how you doing? Mr. Elliott here. Starting off second semester, starting it strong. Actually, we aren't starting it strong because Elliott, due to power out, didn't get to do his first video lesson like he wanted to. So this is actually our second lesson. This is after the discriminant lesson. We're going to learn all about complex numbers here. Dates, writing dates on your notes. If you're watching this in class, today is January 24th. If you're watching this at home the night before, it's still January 23. But you might just want to write January 24 because this is the lesson that pertains to the practice that we'll be doing January 24. So even on my website, I'm going to put this in on January 24, it's always a good idea to watch it the day before on January 23. In fact, I'm going to post it twice. Oh yeah, you'll see what I mean. Now, in these problems, I'm going to be doing 13 examples, and in these 13 examples, we want to leave our answer in complex form. And what you're going to learn in the instructional part tomorrow in class is that complex form is a plus bi. You also need to know that, as we talked about on Monday, that the square root of -1 is equal to I, but because of that, I squared equals -1, I cubed equals -I, and then that means I to the 4 actually equals +1. And you need to know this in order to pull off this first example, example number 1. Let's get it I to the 72. Well, you want to divide out as many I to the 4s as you physically can. So kind of on the side, do your 72 over 4. And that actually divides evenly, doesn't it, to 18? So that means that this is equivalent to I to the 4th raised to the 18th power, because 18 times 4 is 72. Which means I to the 4 is equal to 1, so this is equal to 1 to the 18, which is equal to 1. So I to the 72 is actually equal to +1. Interesting. Example number 2. I to the 94. I to the year Elliott graduated high school. Same thing. How many I to, well, I guess on the side you could do your 94 divided by 4. Let's see. I'm going to cheat here. I'm going to use my calculator. 94 divided by 4. Let's see. That is 23.5, or I'm going to say 23 with the remainder of 2. And this is handy because I can use this to say that I to the 4, I know that 23 groups of I to the 4 is going to multiply out. 4 times 23 is 92, which leaves me a remainder of 2, which means that, oops, sorry, gotta start over. So this is equal to I to the 4 raised to the 23. As I just said, that covers 92 of them, and we need 94. That's the remainder of 2. So what's left over is this I squared. The I to the 4 to the 23, I to the 4 becomes 1, and 1 to the 23, start over again. I to the 4 to the 23 becomes 1 to the 23 times I squared is -1. 1 to the 23 becomes 1, which means this answer is -1. Now, you know how I say, if you do a problem wrong, redo it? This is sloppy. It doesn't look good. So I'm going to do it another time, just really quick. I to the 94. This was a good first step, so it's I to the 4 to the 23 times I squared, which became 1 to the 23 times -1, which just became -1. So now I've got this nice clean problem here, and it doesn't have all these crossouts like this. So I'm actually just going to get rid of all this stuff. Well done, Elliott. Okay, that's I to the 94. Example 3, what about I to the 55? I to the 55. So let's see, 55 divided by 4. Let's see, 12 is 48. So 13 is 52. So it's 13 with a remainder of 3. So that means that of the I to the 4s, you can kind of take 13 of those groups. That covers 52 of the i's, which means what would I have left over, which would be an I cubed. I to the 4 is a 1, so this is 1 to the 13 times I cubed works out to be negative I. So I change this I cubed to negative I. The 1 to the 13 is just a 1, which means the answer is negative I. So that's how you do a big I exponent. Now just a bunch of other examples, and these are just little things that you can do, kind of just order of operations stuff using imaginary numbers. 8i minus 3i's. What's 8 minus 3? It's 5. So if you have 8 imaginaries minus 3 imaginaries, what you're left with is 5 imaginaries. Done. Number 5. I times 4i. Actually, it probably wouldn't look like that. It would probably just look like this. I parentheses 4i. Anyway, this is 1i times 4i, which is 4i squared. Then what happens to I squared? I squared is equal to negative 1, which means this is equal to negative 4. Example 5, or that was example 5. Example 6. Let's say I had 2i times 3 minus 5i. This is a distribution problem, so let's distribute. 2i times 3 is 6i. 2i times negative 5i is negative 10i squared. I squared becomes negative 1, so 6i minus 10 times negative 1. This becomes 6i minus negative 10, which becomes 6i plus 10. Should be noted that in my work, I would normally just go straight from here to here. 10i squared becomes negative 10, so this becomes 6i plus 10. Now, we're not done yet, because complex form is a plus bi. To be proper complex form, you need to do the real number plus the imaginary number. So we can just flip-flop these, and it becomes 10 plus 6i. Just make sure you hold on to their positive or negative values. All right, number 7. Square root negative 16. We talked about this in class on Monday. This is like having square root of negative 1 times square root of 16. Square root of negative 1 is I. The square root of 16 is 4, but we do not write it I4, we write it as 4I. I normally jump straight from here to here on my work. Actually, I normally just jump straight from here to here. Example number 8. Square root negative 20. Same type problem, except this one can't be simplified. It can't be fully simplified, so we can only halfway go. So I break this into parts. Square root, start over. Square root negative 1 times what divides out of 20 that I know the square root of is 4. What's left behind is a 5. Square root of 4 is 2. Square root of negative 1 is I. And the square root of root 5 is just, well, we don't know that square root, so it just stays root 5. So you put the real number first, then the I, then the root. That's just the way it is. I can't tell. I don't have a reason why. That's example 8. Any questions? Oh yeah, no one's here. Number 9. But if you're watching this video in class, please, anytime you have a question, stop the video in the middle of the video lesson and ask that question. That's the beauty of these video lessons. You can go however fast or slow through these lessons as you'd like. I have 2 plus 5i plus 6 minus 8i. Well, real numbers can only be added, guess what, to real numbers. And imaginary numbers can only be added with imaginary numbers. 2 plus 6 is 8. 5i minus 8i is negative 3i. So 8 minus 3i. That's it. Make sure you put the real number first, the imaginary second. If you write it as negative 3i plus 8, I will mark it wrong. You'll just lose a point, but hey, losing a point's losing a point. Okay, now these are the good ones. Now we're getting into good problems. Square root negative 27 minus square root negative 48. Star this one, everybody. I'm putting one like this on the daily quiz on Wednesday. Just letting you know. Wait. Yes, that's when I'm putting it on the daily quiz. Square root negative 27. Let's see. This one breaks into square root negative 1 times square root 9 times square root 3. Square root of 9 is 3. Square root of negative 1 is I. This just stays root 3. So I have 3i root 3 minus. This one becomes square root negative 1 times, I can divide out a 16. 16 times 3 is 48. And square root of 16 is 4. Square root of negative 1 is I. Square root of 3 is just root 3. Now, you can add these if they're both imaginary and if you have matching roots. And they're both imaginary, they both have matching roots, so then at that point you can subtract them. 3 minus 4 is negative 1, so this is negative 1 I root 3, or if you just answer as negative I root 3, that's also equivalent. So side example, if I had like 2i root 3 minus 3i root 5, I'd have to leave this one just like this because they're both imaginary numbers and they don't actually mix. Shoot, I don't think is that accurate? Yeah, I guess. Oh man, you're never going to see one like this again. Not this year, everybody. But if you were to do this one, technically, what we'd have to do is you'd have to factor out that I, and so you'd be left with I times 2 root 3 minus 3i root 5. No, just 3 root 5. But like I said, you're not going to see one like this anywhere in the near future. Ones that you'll see, they'll have the matching root with the i's. All right, 3 more examples to go. Example number 11. 6i in parentheses quantity cubed. Cube both of the things inside the parentheses, so this becomes 6 cubed, I cubed. 6 cubed is 216. I cubed is negative I, which means this is equal to, and it's multiplied, so it's negative 216i. I would not normally show this middle step. I would normally just go straight from here to here. 2 more to go. Example 12. Foiling problem. 2 minus 3i times 5 plus 4i. Foiling problem. First you multiply the firsts. 2 times 5 is 10. Outers. 2i times 2 times 4i is 8i. Inners. Negative 3i times 5 is negative 15i. Lasts. Negative 12i squared. All right, next. 10 plus 8i minus 15i is negative 7i. So I have 10i plus negative 7i. This negative 12i squared. I squared becomes negative 1. Negative 12 times negative 1 is positive 12. So at this point I'm telling it at 10 minus 7i, negative times negative, is positive 12. And then you need to answer in complex forms. You have to go the real plus the imaginary. 10 plus 12 is 22 minus 7i. Just so you know, people that are minimalist on work, I typically jump straight from here to the answer. 8i minus 15i is this negative 7i. This negative 12i squared becomes positive 12, and 12 plus 10 gives me this 22. Last example, number 13. Oh man, I really don't want to put it on a new piece of paper, but I have no choice. 13. 5 plus 3i quantity squared. Don't answer 25 plus 9i squared. Don't do it. Don't do it. You need to remember, this is just like a foiling problem. It's 5 plus 3i times 5 plus 3i. Fully FOIL, or distribute. 5 times 5, 25, plus 15i, plus 15i, plus 3i times 3i, 9i squared. Okay, 15i plus 15i is 30i, so I have 25 plus 30i, 9i squared. I squared becomes negative 1, so instead of being plus 9i squared, I can just write minus 9. And then you got to add all the reals and imaginaries. 25 minus 9 is 16, so we end up with 16 plus 30i. And those are your 13 examples. Now, if I were you, make sure you're comfortable with all 13 of these examples before getting into the practice. Make sure you can do them all. If you have questions about any of them, please remember to ask. Ask about how to do these problems before getting into the practice. If you know how to do the problems from the examples, you'll know how to do the problems from the practice. But if you can't do the examples, you won't be able to do the practice. So don't start the practice until you understand those examples. Last thing, don't forget everybody, Elliot loves you, and I'll see you tomorrow. Have a great day. Bye-bye. Or bye. I'll see you tomorrow, or I'll see you in a couple minutes.